Hello everyone, I'm Kaoudi from TU Berlin, and I will talk about training data generation for ML-based query optimization. In Agora, an open data ecosystem we're building, users not only contribute datasets, algorithms, and systems, but can also ask the ecosystem to execute a task for them. In this case, the execution layer of Agora is possible to determine where to execute this task, meaning in which system or even in which location. And for that, some query optimization is required. Now, we know from previous that there are a lot of problems with the traditional cost-based optimization in such settings, such as it's very hard to fine-tune all the hyperparameters for all the cost formulas, or that these formulas assume linear functions which do not really depict reality. So for that, machine learning comes to the rescue. So by replacing the cost model with a machine learning model, there is no need of a linear assumption anymore. We don't have to manually tune any cost formulas, and we still achieve good performance by choosing good plans. However, we know that machine learning models are data hungry, so we need a lot of training data. So a naive solution to generate such training data is to manually create thousands of plans, so both good and bad plans, extract the features for each of the plan, and then execute all the plans to collect their labels, which means their execution runtime. However, this is very tedious and time-consuming, and let me show you why it's time-consuming. Here you can see the time that it required us to collect the runtime of a different number of jobs on just 1 gigabyte of data, and to collect the labels for 10,000 queries, it would require a bit more than 4 days. Now, if we extrapolate that to 1 terabyte of data, that would take us more than 6 months. So for that, what we propose is, instead of manually creating plans, we synthetically generate plans based on an initial small workload that the user has in mind. We extract similarly the features for each plan. And now, instead of executing all the plans, we execute just a small sample of them and forecast the rest. For that, we have built DataFarm, which consists of 3 main steps. In the first step of plan generation, we output abstract plans. In the second step, we instantiate these abstract plans with the join predicates and selection predicates based on the input data. And in the third step, we generate the labels. So we collect the runtimes of these synthetically generated plans. For that, we sample some of them, execute them, and get the real runtime. We create a machine learning model, which is then used to forecast the runtime of the rest query plans. Now, if we are satisfied with the results, so if our prediction quality is good, we just output the training data. If not, we go back and sample more jobs and execute them, build another machine learning model, and so on until we get a satisfactory training data set. To further enhance the process of labeling, we have decided to include the human in the loop, who has insights on which jobs actually would be useful to execute and which not. And this is done via a very insightful and intuitive user interface where he can profile different jobs and compare them. Thank you very much.